Chapter 9, question 38 on graph paper. Plot and connect the points from quadrilateral QUOP if its vertices are located at Q 54, U 24, O negative 110, and P 610. And the first thing we're asked to do is find the perimeter of that and then write your answer with appropriate precision. Meaning probably we're going to round this because all of our points are recorded to the nearest whole number. We're going to record our answer to the nearest whole number. And then it asks us to rotate that quadrilateral 90 degrees. That's clockwise, as the clock would turn, about the origin to form a new quadrilateral Q prime, U prime, O prime, P prime. And what is the slope of Q prime, P prime? So I went ahead and pre-plotted these points here. And finding the perimeter, a couple of these are going to be super simple, right? For example, from O to P, you can see I'm going from negative 1x to 6 for x. So that's a change of 7 units. And I could count that, right? It's 1, 2, 3, 4, 5, 6, 7 jumps. Along the bottom from U to Q, you can see x is going from 2 to 5. That's a jump of 3 units. So part of my perimeter is I've got a 7 and a 3, 10. But then the other two parts I'm going to have to figure out using the Pythagorean theorem. Let's go ahead and do QP first. So I can see that there's this small right triangle here I could refer to. And it has these two parts. It has a base here, or this leg is only a single unit long. And the other leg, if I look at it, I'm going from y is 10, y is 4. When I go from 4 to 10, that's a jump of 6 units. And I could count them 1, 2, 3, 4, 5, 6. But I like looking at the y's and then just doing the subtraction problem. So that's 6 units long. So this length, right, this length from P to Q, the length of this hypotenuse, I'm going to give this a variable name. I'm going to call this A. I could say that a leg squared, right, plus the other leg squared is the hypotenuse squared. And yes, I labeled that hypotenuse A, so I'm saying it's A squared. Of course, this is 1, this is 36. So we're looking at, no, I wrote 37. I was getting ahead of myself, 36. When I combine them, I get the 37. So that's A squared. So I know that the length of A is the principal root of 37. So A is root 37. So that's one part of the perimeter. And then the final part of the perimeter, I'll call this hypotenuse over here. I'll call this, I'll use H. And you can see that there's this leg right here along the line x is 0, or no, x is 1, and then this. So the bottom piece there, I'm going from x is negative 1 to x is 2, so this is 3 units long. The other one's going from y is 4, again, up to 10, so this is still 6 units long. That's just the height of this thing, right? 6 units. But the length of the side, h, from O to U, h squared is going to equal 6 squared plus 3 squared. So we're looking at 36 plus 9, which I believe is 45. So then h is the principal root of 45. So if I want to calculate my perimeter, I just need to do a bit of addition here. So let me grab a calculator, and I'll figure out the square root of 37. And let me also calculate the square root of 45. And let me add those. So I'm going to go, this is the square root of the 45 plus this is the square root of the 37. And then to that, we need to add 10, right? Because we had 7 along OP and 3 along UQ. So plus 10 and we get 22.79. So if I was going to round that to appropriate units for the context of this problem, I'm going to round that to just 23. So I'm going to say the perimeter is 23 units. We'll come over here. 23 units. And they don't tell me if these are centimeters on the grid, so I'm just using the generic units. The other question, I'm going to do the rotation, but I'm going to cheat to figure out this question because it says, hey, if you rotate the entire thing 90 degrees about the origin, it turns out that all the original sides and the new sides are all going to form 90 degrees together, right? They're all going to meet at right angles. So figuring out this slope, right, is just a matter of knowing what the slope of QP is. QP. If I know the slope of QP, I can just get the opposite reciprocal of that, and I would know the slope of Q prime P prime. So let's look at the slope of QP. And I can see I've already got a slope triangle here, kind of, right? I've got a rise of, if I was to write this on the inside, I've got a rise of 6 units and a run of 1 unit. So this thing has a slope of 6, right? That's the red line. It has a slope of 6. So after the rotation about the origin of 90 degrees, then I would know that Q prime P prime would have to have a slope that is the opposite in sign of that. So it was positive, so it's going to be negative, and the reciprocal. So after the rotation, it should have a slope of negative 1/6. So what we're setting out to do is to rotate this entire thing 90 degrees about the origin. So we can think about, we're going to have this 90-degree rotation around the origin, the point 0, 0. And to help me think about that sometimes, it's kind of useful to just look at some of these little slope triangles. So for example, if I was to go from the origin to point U, I would see that I've got this thing right here, and you can see that I'm going up 1, 2, 3 units, and I'm going over 2. I'm going up 1, 2, 3. I'm up 4 over 2 units. So what I really want to be able to do is I want to create a right angle with this line right here, right? And to do that, I can just take the opposite reciprocal slope. That right there was up 4 over 2. If I was to go over 2 and down 4, 1, 2, 3, 4. This point located here should be where U's going to. So this should be the point U prime. Now, I don't exactly see this yet, but I'm going to keep going with this tact and see how far this gets me. Let me use another color for the next one. I'll use this bright green. And now from the origin to Q, right? Now I want to make a right angle with that, because as I rotate this entire thing 90 degrees, right, this whole line segment that I've drawn is going to rotate also. Well, that slope from the origin is up 4 units over 5 units, up 4 over 5. What I'm going to do is I'm going to go over 4, and then I'm going to go Okay, I'm going to just try it. Well, no, I'm going to go over 5 and down 4. Let's see, over 5. 1, 2, 3, 4, 5, and then down 1, 2, 3. Okay, if I do that, this point right here is that this does not look right. It isn't right because this is not a right angle. if I want to make, let's see, this line, it helps if I write the slope. This green line has a slope of 4/5. So what I want is I want a slope from that point of, that's a rise of 4 and a run of 5. I want that's up 4/5. I need a slope of -5, 4. So I need to go down 5 and over 4. Okay, so I'm going to go down 1, 2, 3, 4, 5 and over 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Can't possibly be right. I believe that green line's correct. The blue one now is the one, like, no, the blue is not what my problem is. So this, let's think about the slope. So the blue one was up 4/2. 4, 2. So I need a slope of -2, 4. So I need to go down 2 and then over 1, 2, 3, 4 right here. Okay. I think I'm getting somewhere. I think this is now U prime, and down here this is definitely Q prime, but I want to keep going. So this is the first part of my new shape, right? This piece right here gets rotated down to this one. So now that I look at these coordinates, the coordinates are actually kind of helping me figure this out. So if I look at the coordinates there for point P, that is a rise of 10 and a run of 6. A rise of 10 and a run of 6. So what I need to do, that's back to the origin, right? Again, I'm thinking about these lines from the origin out to these points. That's the slope of that line. That's up 10 over 6. So I need to go down 6 and then forward 10 for the image point. So I'll go down 6, oops, and then over 10 units. So I'm right here. And this now should be the point P prime. And then the last thing I've got to figure out is where O goes. O was running along this line, and O had a slope of, let's see, the rise was 10 and the run was back 1. So now I'm going to take the opposite reciprocal of that. I'm going to go up 1 and forward 10. So I'm going to go up 1 and over to 10. So this should now be the location of O. Okay, so I think I have now the new shape, the new shape that results from the rotation. And that's definitely me kind of just sitting here like, I don't know anything about this. Let me try and figure this out. But I do know that when I do that rotation 90 degrees, the slopes are going to become opposite reciprocals. So that was kind of key for me. Now, there's something that happens. And if I look at where my points landed, I can kind of figure out a rule here. So look, if I look at where P prime is now at 10, 1. No. P prime is at 10, -6. This is 10, -6. And I'm comparing that with P, which was 6, 10. That could be helpful. Let's look at this other point here, O. O was at 10, over 10 and then up 1. And I compare that with the original O. This is O prime. The original O was at -110. And Q is at 4, -5. So I went over 4. This is at 4, -5. Q prime. And compare that with the Q. And then the last example we have there is U. U was at 2, 4, and it went to 4, -2. Now the reason why I point these out is if we were to make a little table of values of them. So here's P, and that went to 10, -6. And then let's look at O. O was at -1, 10, and that went to 10, +1. Let's look at Q. Q was at 5, 4, and that went to the point 4, -5. And the last example I have is U. U was at 2, 4, and U maps to the point 4, -2. So when I look at this mapping, I can see if this is X and this is Y, right? From these examples, I can say, well, look what's happening. X and Y are switching places, right? So what was the Y becomes the X. So that's me showing this, right? This was Y, but it jumps into the X place. And it looks like I'm taking what X is, and the opposite of that, you can see what X was 6, it became the opposite of that, right? X was -1, the opposite of that. It was 5, the opposite of that. It was 2, the opposite of that. So what was X, the opposite of that becomes Y. So if I want to do a 90-degree rotation, right, clockwise about the origin, this is a rule that will map those points. Now, I never want you to try and memorize those rules, but if it turns out you've got to do a lot of those mappings, it's way quicker to just think about this, come up with the rule, and then you could apply that rule again and again. So if I would have known that to start with, I could have done this a lot quicker. But again, it's not about what you know, it's about what you're capable of figuring out. And it's also helpful to know things too. Boy, that was not intended to be 17 minutes.